Does everything exist in an objective reality wherein the universe obeys fixed, immutable laws? Or is there no such thing as an objective reality, meaning all is flux, all is change? Let's talk about that. For today's video, we will be sourcing our material from the book authored and published in 1995 by Ian Stewart, Nature's Numbers, the investigation of patterns, shapes, numbers, and movement in the world around us. For our topic, let us all refer to page 47, which is chapter 4, The Constants of Change. For centuries, people have debated on whether nature's behavior revolved around rigid law or flexible flux. So what do we mean by these? So rigid law actually pertains to systems that are fixed and cannot be changed. This is opposed to flexible flux, which pertains to systems that constantly change. So in the rise of science, rigid law had actually governed this, but because of increasing science, a lot of people switched to flexible flux. This is in correlation to page 47, paragraph 1, wherein Greek philosopher Heraclitus had actually said that you can't step into the same river twice. This debate had continued on until mathematician Sir Isaac Newton realized that not only does rigid law and flexible flux coexist, but that law actually generates flux. This means that change actually obeys law.
To better visualize this, let's take for example the motion of a cannonball. Horizontally, parallel to the ground, the speed is constant, but vertically, it is a bit more complex. It can be seen here that initially, as time increases, the height also increases. That is until it reaches its peak right at the middle, wherein you can see the height decreasing as time continues to increase. Height can go up from 0, 45, 80, 105, 120, 125, and back down to 120, 105, 80, 45, and 0. It can be seen here that the velocity decreases as time increases. Velocity can be seen to decrease from 50, 40, 30, 20, 10, 0, negative 10, negative 20, negative 30, negative 40, and negative 50. Below, you can see the constant acceleration, the rate in which the velocity decreases. Acceleration can be seen at a constant of negative 10.
The question now becomes, if all else is flux, why is acceleration constant? This is because the acceleration, or better known as a constant downward acceleration, actually refers to gravitational force, which is more accurately 9.81 meters per second squared. There are actually two elements to further explain this. The first being that Earth pulls down weight all equally, whether you'd be on the first floor of the building or the 60th. The constant downward acceleration is still the same. It would have to take a sufficiently large distance to have a greater acceleration, perhaps the distance from the Earth to the Moon. Secondly, if we are to assume that we'd be on a planet with a greater gravitational force, let's say Jupiter, although the constant acceleration would be larger, it would still be constant to every weight applied. This is the essence of Newton's law of motion. The law states that mass times acceleration is equals to force.
A whole lot safer than the time he stuck his sewing needle into his eye socket to figure out if
Newton stated the three laws of motion, but the modern approach views them as three aspects of a single mathematical equation. And so for this, we will be referring to it as a whole by given a body's mass and the force acting on it. We can solve for acceleration.
Unfortunately, this is the answer to the wrong question. Knowing the acceleration is not enough. We have no idea of the shape of its trajectory. This is where calculus comes in. Newton and Leibniz invented calculus, which provides a technique called integration. This is basically what allows us to obtain knowledge of position at any instant, maybe from knowledge of acceleration at any instant to knowledge of velocity at any instant and versa. And so, this is the answer to the right question. To further understand the concept of calculus, this is basically a mathematical scheme that handles questions about rates of change. The technique for finding rates is differentiation, and the technique to undoing this is integration. These are basically twin techniques of calculus that point in opposite directions, which was evident in the presented figures earlier. If you know one of either position, velocity, or acceleration at any instant, then you can easily work out the other two. Overall, it can be understood that Newton's law of motion teaches an important lesson. The road from nature's law to nature's behavior need not be direct and obvious. It is only by mathematical calculations that the human bridge behavior observed and laws produced.
As physicist Paul Dirac said, God is a mathematician, as stated in page 55, paragraph 1. Nature's patterns and regularities may have other origins, but at the very least, we can say that mathematics is an extremely effective way for us to have a better understanding of these patterns. That concludes our video, and we thank you so much for watching. We hope that you learned a lot, and we'll see you again next time. Bye-bye!
Did you know the meaning of solve has been revised many times? This is because at first, people thought that to solve for something meant to find a formula. This was the only way to work out the occurrence of motion in the early days of dynamics. But when it was too hard to find a formula, they would concede to finding approximation, which led to revision of the meaning to find approximate numbers. But then, nowadays, it can be obtained from theories that deal directly and precisely with the main qualitative aspects of the motion. Hence the meaning of solve being tell me what the solutions look like, and that is how we started to understand nature's patterns in their own terms.